Alright, in this video we're going to look at some special product formulas for when we are multiplying certain types of polynomials, right? There's, we talked in another video, and if you haven't watched it yet, you should, a video I did where we are multiplying polynomials, and I explained how to do that. But if the two polynomials that we're multiplying are in a certain form, then we have, these formulas here that allow us to take a shortcut to figure out what the answer is. Now, these special product formulas are not crucial to know, because if you ever forget what these formulas are, you can always just do what we did in that other video and just set up the multiplication and distribute everything and multiply it out and get your answer. It's just that if you know these formulas, it is a little bit of a shortcut, and you can get your answer a little bit quicker. But again, if you forget the formulas, it's not that big a deal. You just multiply it like you normally would. All right, so the first one, a plus b times a minus b equals a squared minus b squared. All right, so that's our first special product formula. So if we have two binomials and they have the same two terms in them, except one of those terms is positive and the other one is negative, well, then we multiply them out, we just get this a squared minus b squared. All right, so just to kind of prove to you that that's true, let's actually multiply this out. If I have a plus b times a minus b, well, if I do the FOIL method, or if I do my distributing, a times a is going to give me a squared, right? A times minus b is going to be minus ab, b times a is going to be plus ab, and b times minus b is going to be minus b squared, right? And what ends up happening here is this minus ab and this plus ab cancel out because one's a plus and one's a minus, and so what we're left with is a squared minus b squared, which is what we have up above there. Right, so just to prove to you that is true, that a plus b times a minus b equals a squared minus b squared, that's what it is. Now, if you don't remember, if you have something in this form and you forget the formula, to get your answer, all you have to do is exactly what I just did up here. Right, just multiply it out and do the foiling or do the distributing and get your answer, and it only takes like less than a minute to actually do that, so it's not a big deal if you forget the formula, or if you don't recognize that what you have fits this form and you can use a formula for it. It doesn't even matter, just multiply it out and you get your answer. As long as you simplify it correctly, you get the same answer. All right, so again, that's why I said at the beginning that these formulas are not that big of a deal for you to know. All right, the next one, a plus b squared equals a squared plus 2ab plus b squared. This is something that people mess up all the time, right? A lot of people seem to think that when you have a plus b squared, that should equal a squared plus b squared. It does not, right? A plus b squared is not a squared plus b squared. And if you watch the videos I did about the laws of exponents, remember, if you have something in parentheses raised to a power, you're only allowed to distribute that exponent into the parentheses if what's inside here involves multiplication or division. If what's inside here is addition or subtraction, like we have in these formulas 2 and 3 here, we cannot just distribute the exponent, right? It doesn't just equal a squared plus b squared, it actually equals a squared plus 2ab plus b squared. Right, so once again, I'll show you why that is. Remember, a plus b squared, when I'm squaring something, it means I'm multiplying that thing by itself. So this is a plus b times another parentheses a plus b, right? That entire parentheses multiplied by itself, that's what this means. That whole parentheses squared, the parentheses times itself. And then if I multiply that out by distributing, right, a times a equals a squared, a times b equals ab, b times a equals another ab, and b times b equals b squared. Right, and notice this ab and this ab up here, like up here, those two canceled out because one was a plus and one was a minus. Here they don't cancel out because they're both positive. Right, so what we get is a squared plus 2ab plus b squared. Right, that's why this little thing over here that people always try to do is not correct, right? A plus b in parentheses squared is not just a squared plus b squared, right? Don't make that mistake. It's really common. People do it all the time. You got to remember, when you have something in parentheses raised to a power, it means the entire parentheses multiply by itself, and you have to actually multiply it out, which gives you that extra term in the middle there, right? So again, if you don't remember what this formula is, that's okay, as long as you remember that it's not just a squared plus b squared. If you just go ahead and multiply it out like I did here, you'll see that it comes out to this, which is not a squared plus b squared. All right, the third one up here, similar, except there's a minus b instead of a plus b. But if we have a minus b squared, also not just a squared minus b squared, right? It's a squared minus 2ab plus b squared. right? And I'm not going to or write that one out and do it all. If you want to confirm it, just like I did for these two up here, if you just do a minus b times the parentheses a minus b, just like I did here, and multiply it out, you'll see that this is what it comes out to, right? So I'll leave that one up to you. If you want to confirm that, you can do that. Right, the last two up here are when we have a binomial raised to the third power. Right, so if I have a plus b to the third power, that's a to the third plus 3a squared b plus 3ab squared plus b to the third power. Right, notice a plus b to the third power, it's not just a to the third plus b to the third. Right, so a plus b to the third power. Again, when I have a parentheses raised to a power, if that parentheses has addition or subtraction inside, it's not just distributing the exponent. Right, it's not just a to the third plus b to the third. We can see there's actually a lot more to it than that. Right, to confirm this one, since you have a plus b to the third power, you would have to take that parentheses a plus b and multiply it 3 times. Right, so you would have to first take 2 of them and multiply it out, and then take the third one and distribute that to everything. And when you clean it all up, this is what you'll come out with. Again, I'm not going to multiply all that out. I'll leave it up to you if you want to confirm that this formula is true. This is what you do: a plus b times a plus b times a plus b. Do all the foiling and the multiplying. This is what you should come out to. Right? But again, the key thing to remember is it's not a to the third plus b to the third. Right? I keep harping on that because, like I said, it's a mistake that people make all the time, and it's really frustrating because you tell people all the time that that's not what it is, but still people see this and say, oh, that's a to the third plus b to the third. Don't do that. All right, the last one, a minus b to the third power. Same idea, right? Just like this one up here. It's a to the third minus 3a squared b plus 3ab squared minus b to the third. Right, so similar to the formula up above, but a little bit different. Obviously, because now there's a minus here, so a couple of these terms are negative, whereas up here they were positive. So again, for these formulas, it's not crucial that you memorize what these formulas are. In algebra and pre-calculus and calculus, there are a lot of formulas that are very important for you to know what they are and to memorize the formulas. These are not that important to memorize, right? I always try to be honest with people and say, well, this you really do need to know, this one not so much. These are the not so much category, right? Because remember, if you forget that a plus b squared equals this, all you have to do is do a plus b times a plus b, and it takes you like an extra minute or two to multiply it out, and you'll get the same result, right? These ones down here for something raised to the third power, that's going to take a little bit longer to actually multiply out by hand, but I would rather multiply it out that by hand than try to remember this ridiculous formula and like memorize that and try to stick it in my brain for the rest of the time. I would rather just multiply a plus b times a plus b times a plus b. It'll take a couple minutes, but I'll get this eventually if I do that. All right. So if you have a really great memory, by all means go ahead and memorize those formulas. If not, just remember what they mean. A plus b squared means a plus b times a plus b. A plus b to the third means a plus b, a plus b, a plus b. 3 of them multiplied together. If you remember that and you're able to multiply it out, the formulas are not necessary. Right? Oh, in the next video that I'm going to do some examples where we work with things that involve these formulas. So make sure you check that out to see some examples.